good morning and welcome back to my class on normal distribution. We are talking about continuous random variable, right? So we have discussed different types of random variables, okay, like discrete random variable and continuous random variable. And under that topic, we are now talking about what? If you are saying that any random variable is a continuous random variable, then that random variable must be described by what? Must be described by the density function, okay? So we talked about uniform density function, right? Uniform random variable. We talked about exponential random variable, right? And now it's time to talk about what? It's time to talk about one of the very important, you can say, random variable. That is nothing but a normal random variable, or sometimes we call it Gaussian random variable as well, right? So let me switch to directly our favorite board. So I believe everybody is able to see the screen, right? So this is going to be our screen right now. We are talking about lecture number 19. Already we have done many sessions, right? So you guys have to, watch all the sessions. Okay. So in this session, I'm just going to focus on normal density function, normal distribution. It is one of the very important distribution you can say for gate data science in AI people, as well as for electronics and communication or any branch you are studying, right? Because this topic is not taught in proper manner, right? So let us begin here. So we will talk about normal distribution, basically. Normal distribution. In fact, entire statistics will be revolving around this normal distribution, right? You might have heard about central limit theorem, right? You might have heard about confidence interval in statistics. So this normal distribution plays an important role, okay? Uh, So you have to study this topic very carefully, right? So what is this normal distribution and where do we use this normal distribution, right? Okay. So it is very important in the theory of probability whenever we talk about central limit theorem. Okay. So under normal distribution, basically we have to talk about normal random variable. Normal random variable, right? See, any random variable which is normal. Okay, and it is nothing but a continuous random variable. Okay, we are talking about continuous random variable. It cannot take discrete value, right? Exact value you can say. Okay, it can take, like, random variable can take the value between ranges. Okay, so normal random variable, or sometimes we call it Gaussian. Okay, we call it Gaussian random variable. Gaussian random variable. Okay, so where do we use this sort of random variable? So in statistics, you will be learning central limit theorem. Okay, in statistics, you are going to learn central limit theorem. Okay, so there we will be using this normal random variable, and the density which is associated with this normal random variable, we call it normal density function, or sometimes we call it normal distribution. Okay, and it is also very important to model the noise consisting of many small, you can say, uh, in any situation. Suppose you are sending a message signal from one place to another place, right? Let's say you are establishing a communication between, two destination, right? One destination is, you can say, you are sitting in Mumbai, like me, and somebody is sitting in Bangalore, right? So if you want to, establish the communication, okay, so you will send some message, okay, from here, and it might happen that that message signal can get added with some noise, right? So that you will not be able to identify what Dheeraj sir has sent from Mumbai to me, right? So in order to describe all these kind of scenario, right, you need normal random variable or Gaussian random variable. Okay? So understand. So this is important point to remember. So where do we use normal random variable or normal density function, that you should know first. ठीक है? तो ये एप्लीकेशन का पार्ट हो जाएगा. This is just a, you can say, kind of, okay, these 2 points you have to remember, right? So the very first thing that I will discuss here is the standard normal random variable. Okay, standard normal random variable. Okay, so what are the parameter that describes the standard normal random variable? Is nothing but the mean. Okay, and the variance. Okay, you have to remember mean means expectation as well as the variance. Okay, so if I say something is standard normal, okay, if I say something is standard normal, okay, it means that the mean has to be 0. Please remember that. Okay, if you will find in the question somewhere, if it is standard normal random variable, okay, standard normal Gaussian random variable, so please remember that the mean must be 0, right, and the variance must be equal to 1. These 2 points you have to keep in mind. Okay, for standard normal. Okay, for standard normal, understand? So what you have to remember here is, if someone is saying that the standard normal, okay, so let me start with the standard normal. Okay, so standard normal random variable. Okay, I'm not talking about normal random variable or Gaussian random variable at this moment. I'm talking about standard normal. Okay, please remember this word, standard normal, or sometimes we call it Gaussian random variable, right? Okay, so how do we represent this? The standard normal is represented by, remember this, standard normal. Okay, we write like this. This is n sort of thing, right? N having 0 and 1. What is the meaning of this? N of 0 and 1 means 0 mean and the variance is going to be 1. And the density function which describes this kind of random variable is written like this, f of x small x. Okay, this is the notation that everybody knows, right? How do we represent a density function, okay, for the case of continuous random variables, f of x. Why we are writing this x here is just we are talking about density function for x random variable, right? And it takes the value small x. It is written like this, 1 by square root of 2 pi. Okay, please remember 1 by square root of 2 pi e to the power minus x square by 2, sir. Okay, this is the density function, right? This is the density function analytically, you can say analytical representation, analytical expression, or you can say formula, right, for standard normal density function. Okay, standard normal Gaussian random variable. So if any random variable is continuous, right, it must be described by the density function. If any random variable is not described by the density function, then it is that random variable cannot be continuous. Please remember this. Okay, so ये expression आपको याद रखना पड़ेगा. Okay, this is the density function where the mean is going to be 0. Okay, remember this 0 represent mean and this is nothing but a variance. Okay, so let me write separately. This is nothing but your normal, standard normal. Okay, if it is written like 0 and 1, so this 0 represent mean, mu, and this guy represent 1 represent variance, or you can say sigma x square, right? Sigma x square. So this is simple notation. How do we describe the normal random variable, or you can say the Gaussian random variable? Okay, normal you say or Gaussian you say, it's fine. So expression, you have to remember, expression is going to be f of x is equal to 1 by square root of 2 pi. Now the question is, you may be thinking, sir, why this constant is given, right? I mean, why this 1 by root 2 pi? Why it is there? So that area under the density function will be 1. Okay, See, if you remove this 1 by root 2 pi, okay, so it will not be the valid density function. Okay. So what we are doing now, we are making post-mortem of this expression, right? So whenever you look at fx equal to 1 by root 2 pi, anything other than the function, right? Any constant which is given in the density function, okay, that can be computed by applying the property of what? The area under density function, probability density function should be equal to 1. Simple, you have to just integrate it. Understand? So this 1 by root 2 pi is going to be what? 1 by root 2 pi is going to be, remember this point, these are very important point, guys. If someone is going to ask you, they will give you this kind of question, right? Question. Suppose they will give you f of x. See, this is the style, okay? I think you guys now might have been habituated from past, you can say 18 lectures, right? The way I write these notations, okay? This capital X is very important, which talks about the density function is corresponding to this capital X, okay? So if it is given like this, okay, like let me write k e raised to power minus x square by 2, okay, where x can take any value from minus infinity to infinity, right? This x can take any value, you can say from minus infinity to infinity, guys, okay? This is given. Now the question is, what is the question? Find k. What is this constant which is given in this density function? So if you can recall, okay, if you can recall, okay, the density function, okay, the density function which is Gaussian, or you can say normal density function, right? So simply this k will be nothing but 1 by root 2 pi. Okay, that directly you can write it, okay? You have to know this, understand? Because if you're going to integrate this, okay, like let me apply the definition, area under the PDF, right, must be equal to 1. That is nothing but from minus infinity to infinity, integration k times e raised to power minus x square by 2 dx equal to 1. And it is very popular, integral result, okay, that e raised to power minus x square by 2 dx is going to be equal to what, guys? Square root of 2 pi. One of the very important result, guys. You have to remember this result, okay? You have to remember this result. Understand? So this is going to be a result, okay? So if you plug here, so the integration is going to be k times square root of 2 pi, which is 1. And then k is going to be 1 by square root of 2 pi. Okay. So by intuition, you have to remember these things so that in the exam, you can solve any question very quickly. Okay. Fine. So let me plot this guy, right? How do you can say that the question can be asked like this? How do or how does the Gaussian random variable look like? Okay. How does the GRB look like? तो देखो डेंसिटी फंक्शन का डेफिनेशन क्या था? f of x is equal to formula. This is formula. Okay, 1 by root 2 pi exponential to the power minus x square by 2, right? So let us plot it. Okay, I will give you the trick. Okay, how to plot this guy, right? Can you tell me, guys, what is x square? How do we represent x square? कैसे plot करेंगे? Step number 1. We have to take, this is x-axis, you can say, right? Now how to represent y equal to x square plot? Let me do some rough work here, right? So y equal to x square is means what? It is nothing but a upward parabola of this kind, right? Upward parabola of this kind. But if you're taking negative of that, इट इज अपवर्ड पैराबोला, राइट? ऐसा रहेगा ना, ओके. बट सपोज you take minus sign, minus ax square minus x square and take the exponential. So it is going to be like this. It will be inverted, sir. Down, it will be concave downward now. Okay, you see how we are drawing this picture, right? So this is going to be your y-axis, which is f of x, okay, at 0, okay. 0 here is nothing but a mean. And this guy, the peak is going to be 1 by root 2 pi, okay. Now you can remove this black part because black part is not required now, okay. Okay, you see how beautiful picture we got, right? What we have done here is, हम लोगों ने क्या किया यहाँ पर, since we know that y equal to x square looks like, you know, concave up. Student, those who have watched my lecture, you know, on single variable calculus, they know how to plot a graph. Okay, so concave up x square, right? But if you multiply by minus sign and take the exponential, right? So that becomes the downward. Okay, concave downward, right? Please remember these points. Concave downward. So this is the situation, guys. This is nothing but a bell-shaped curve. Okay, your normal distribution, right? Your normal distribution, or you can say that the Gaussian distribution, right, looks like a bell-shaped curve. Okay, and it is very important, okay, for machine learning people, you know, for communication engineers, right, for computer science people, like those who are crazy about mathematics. Okay, how does the GRV look like? You see, and it is very simple. See, in the interview they will ask, can you draw this Gaussian random variable, Gaussian density function, bell-shaped curve? So you should know the steps, right, how to draw it. Okay, that is fine. So I have told you the you know, steps that you can follow it. Okay, I hope this makes sense to all, right? So this part is nothing but a calculus part, guys. If you look at my lecture, right, okay, on single variable calculus, you know, by Dheeraj sir, okay, you will find all these things like in integral part. Okay, fine. So now the question is, if I ask some questions, right, since we have got the density function, okay, let me ask some question to you. Can somebody tell me what is expectation of x? If it is a standard normal random variable, right? So what will be the expectation? Expectation is gonna be 0, guys. Okay, the capital X here is the Gaussian random variable. Please do remember these points. Okay, the capital X is nothing but a Gaussian random variable. Okay, and the mean corresponding to this kind of distribution, and it is a standard normal. Okay, standard, this standard word is important. The mean is gonna be 0, and the variance, if someone is gonna ask you what is variance, that is going to be 1. Please remember, you don't have to calculate separately, right? As long as it is standard Gaussian normal, okay, standard normal, or you can say standard Gaussian random variable, the mean has to be 0 and the variance has to be 1. Yes, one more question. Sir, अगर जो रैंडम वेरिएबल है वो स्टैंडर्ड नॉर्मल नहीं है, अगर उसमें स्टैंडर्ड जो वर्ड है वो गायब है, if you remove that standard word, right, and it becomes the normal random variable, then how to convert? Okay, that is a very beautiful question, and there is a very beautiful algorithm. Okay, I will tell you, very simple, how to convert any sort of normal random variable to standard normal random variable. हैव यू एवर थॉट अबाउट इट? नहीं सर, हम लोग तो बस फॉर्मूला जानते हैं, हमें जो टीचर फॉर्मूला पढ़ा देते हैं बस हमारा गेट में रैंक आना चाहिए, हमें जानने की जरूरत नहीं है। लेकिन पैकेज तो हमें चाहिए 50 लाख का। वांट टू गेट इनटू यू नो Amazon साइंटिस्ट, ओके, अप्लाइड साइंटिस्ट एट Amazon, है ना, मशीन लर्निंग सीखना है। लेकिन बस, है ना, तो ये डिफरेंस आपको यहां पता चलने वाला है। देयर इज अ ब्यूटीफुल एल्गोरिदम। आप स्टेप बाय स्टेप चलो, राइट। I started with normal random variable. I told you about the application. Okay. And then what I told you? Then I told you about the standard normal random variable. And corresponding to that, I talked about the density function. ठीक है। अब डेंसिटी फंक्शन दिखता कैसे है सर? बेल शेपेड कर्व के उसमें दिखता है ऐसे। देखो यहां पर, इसको अच्छे से देखो, थोड़ा ब्यूटीफुल पिक्चर है ये। It is symmetrical, guys. You can say that. You can talk about symmetrical about y-axis. Okay, it is symmetrical about y-axis. Okay, it is symmetrical about y-axis. Remember these points. It is symmetrical about y-axis. Okay, you can have a look. Gaussian random variable, if it is standard normal, so it will be symmetrical about y-axis. Okay, what is the meaning of symmetry? If you look toward negative of the x and if you look toward positive, okay, it looks same only. Okay, understand? Symmetry means if you cut something from the, okay, in two parts, both parts are going to be similar. Okay, they look similar, understand? So your standard normal curve is going to be bell shaped. Okay, it is very important. ठीक है, for central limit theorem in statistics. ठीक है, fine. So now the question is what, guys? General normal random variable. How does general normal random variable look like? ठीक है, the question is, let us talk about general normal random variable. Okay, or you can say that Gaussian as well. This word is important, Gaussian. Okay, general. Now it is not standard. Okay, it is not standard. Okay, for general normal random variable, the mean can be anything, right? The variance can be anything other than 0 and 1. Okay, they can be anything, right? Okay, so how does general normal look like? So general normal, how do we represent them, right? So we can say that this is nothing but n only, but here mu and sigma x square, you can say, if the random variable is capital X. Okay, sigma square or sigma x square, right? And what is the analytical formula for this? Formula is gonna be look like this. Okay, 1 by, okay, remember this definition, 1 by sigma x root 2 pi e raised to power minus x minus mu whole square upon 2 sigma x square. I hope this makes sense. This formula is very easy, right? So e raised to power minus in the bracket x minus mu. Okay, so what you're doing here is you are shifting your entire curve. Your curve is getting shifted toward right, okay, by mu. See, in single variable calculus, you might have seen if something is like any constant is added or subtracted by the इंडिपेंडेंट वेरिएबल, ओके, एक्स, तो शिफ्ट हो जाता है आपका कर्व। ठीक है, तो ये आपका क्या है? स्टैंडर्ड नॉर्मल है गाइस, सॉरी, इट इज अ जनरल नॉर्मल, राइट। अब आपको लगेगा सर ये हम याद कैसे करेंगे? देखो, इसको बार बार आप लिखो, यू राइट लाइक दिस, दिस इज एफ ऑफ एक्स 1 by sigma x square root of 2 pi. Okay, see, there was no sigma x. Here sigma x is there. Exponential to the power x minus mu का whole square by 2 sigma x square. Yeah, hi everybody. So we are back now. Sorry for interruption. You know, it happens. I will tell you the reason in the next session, right? So general normal random variable we are talking about, right? We have discussed the standard general normal, right? Standard general normal random variable, and this is general normal random variable, right? So I'm in Mumbai, and this you know Mukesh Ambani ji disconnected my internet all of a sudden. Okay, that 5G. Okay, again I had to make it. Okay, that's the reason there was some interruption. It's fine now, right? So general normal random variable, that is nothing but your uh, the normal random variable which is having the expectation mu other than 0, right? And it is not going to be symmetrical. Please keep in mind this. Okay, it will not be symmetrical, okay, about bi-axis, because the mu is not 0, right? The mean is not 0, but your curve is going to be same, and now the curve is going to get shifted from the origin to the new mean, you can say, right? So how do we plot that? कैसे हम लोग plot करेंगे, that we are going to see. ठीक है? So this was the idea. I think we stopped here, right? तो ये आप याद रखना, the density function, right? This is how the density function looks like. Okay, and let me plot that the general normal standard. Okay, here you have to remember that this sigma x is going to be greater than 0, which is nothing but your standard deviation. Standard deviation. Okay, so in order to understand everything, you have to watch all the sessions, right? People, those who are new to this class, okay, they have to watch everything, right? So now the spread of this, you can say the spread of the Gaussian curve, right, depends upon the standard deviation, right, or a variance, you can say. If sigma is small, right, if sigma is small, then it is going to be narrower, right? If sigma is large, right, so you can say that starting like this, you have to start with this kind of a curve, right? But at the end of the day, you have to draw this kind of a curve. Okay, finally, so we are back now, and because of some internet issue, we got interrupted. It's fine, right? So, what I was discussing about is general, you can say general normal random variable, and I showed you how do we graph this density function, right? So, please have a look. And I was talking about this right part. I mean, this spread is going to be this is nothing but a spread, right? Spread is going to be larger, okay, if sigma is large. Okay, that you have to remember, right? And if this spread is narrower, it means sigma is going to be small. So if it looks like this, it means this is going to be your Gaussian curve, right? It is going to be narrower, right? Here you see. Okay, so but let me remove this part which is not a required part. We have drawn this to understand ourselves. Okay, कैसे डेंसिटी फंक्शन को ड्रॉ किया जाता है, दैट यू हैव टू कैप्चर इट, ओके, फ्रॉम हियर. So first of all, you have to draw the x square part, then you have to multiply by -1. Okay, so it will become the downward, concave downward, then you have to take the exponential, right? So I hope this makes sense to all guys. This is nothing but your you can say that general normal random variable, right? Understand? So please remember these points. And so in case of, suppose general normal random variable is given, right? So the question will be, how do we convert? How do we convert into standard normal Gaussian random variable? Okay, this is very important question, and in the exam they will ask you, right? I mean, you should know how to convert it. Okay, you should know how to convert it, irrespective of your branch, whether you're from computer science or data science or electronics or electrical engineering. You should know all these things. Okay. So my standard normal looks like this. You have to go through these lines. Okay, yeah. So you just have a look this, guys. The single most important random variable type is the normal, okay, random variable, which is nothing but the Gaussian as well, also known as Gaussian, and the parameterized by the mu and the variance sequences sigma square, or sometimes equivalently written as the mean and the variance, like this. Okay, you can say that the mean and the variance, okay, like this. If x is normal random variable, so we write like this. Okay, this is nothing but your general normal random variable, and the normal random variable is important for many reasons. Okay, and these reasons you have to remember. Okay, random variable is important for many reasons, and it is generated from the summation of the independent random variable. You know that I told you also, in the same sample space you can have many random variable. Yes, in the same sample space you can have many random variables. Okay, so if you're going to add them, so overall density function is going to be Gaussian only. See, each random variable has got, suppose, different types of density function. It can be exponential, it can be uniform, but suppose you are adding many random variables. Okay, and if you're going to find the density function, right, so it is going to be normal density function only. The result will be normal. Okay, that is what the idea here is. So the normal is very important. It is generated from the summation of independent random variable, right? You have to add many random variable, so you will get normal, and as a result it occurs often in nature. Understand? So many things in the world are not distributed normally. Please remember these points. Okay, okay, so you can always have the approximation. Yeah, the density function is going to look like the normal density function. The distribution is going to be normal, but many things in the world are not distributed normally. Okay, in general you can't say. Understand? So but data scientists and the computer scientists model them as normal distribution anyways, guys. Do you know this point? Okay, so but why? Because it is most conservative modeling decision that we can make for a random variable, while still matching a particular expectation or average, you can say, or the variance is nothing but a spread, okay, about the mean. Okay, it is nothing but the spread about the mean. Yeah. So I have given already everything, and how to write the formula for standard normal, how to write the formula for general normal, right? If you forget that standard word, right? And how to plot the density function. Okay, what are the corresponding mean and the variance, right? That is very important to remember, right? And if you add two random variable, suppose one random variable has got the density function as normal, second random variable has got the density function as normal, the overall density function will be the normal only. Okay, this is very important to remember, right? So how does the density function look like? I told you also, the density function look like this. I mean, the formula looks like this. This is the density function. Okay, this formula already I have told you, right? I hope this makes sense to all. Yes. 1 minute. Let me. Yes. Now the question is, how can we convert? How can we convert this Gaussian random variable to standard Gaussian random variable? The question क्या होगा हमारा? Let me write that question. How can we convert? Okay, the Gaussian random variable to standard Gaussian, right? Random variable. Okay, that is the question of the day. So can you share some thought about it? कैसे convert करते हैं? So see, if you have got a density function, right? If you have got the density function, so you can compute the probabilities, right? Yes. But if it is a general random variable, so computing integration will be very difficult. Okay, because probability means what? If density function is given, in case of continuous random variable, what is the density function? The density function is going to be, the probability is going to be the area under the density function, right? And if it is general, you can say normal random variable and the density function is given. So computing probability is going to be very difficult, guys. You cannot compute the normal probabilities because the integration is going to be very difficult. So यहाँ पर धीरज सर काम आने वाले हैं आपके, right? धीरज सर is going to tell you the algorithm so that you can compute the probability. You can compute that integration, right? Please remember these points. ठीक है? There is a problem in life and that problem in life I am going to solve. ये मेरा काम है, ठीक है? So let us see how we can convert any Gaussian random variable to standard normal Gaussian random variable, right? That is the idea. Okay. We'll talk about that. Okay. The question is how to convert Gaussian random variable, or you can say here general Gaussian random variable. Okay. हम बताएंगे अभी. Just I am going to tell. Okay. So now, okay, एक टॉपिक और समझना है हमें, दैट इज नथिंग बट लीनियर फंक्शन ऑफ नॉर्मल रैंडम वेरिएबल. लीनियर फंक्शन ऑफ नॉर्मल रैंडम वेरिएबल, ठीक है. व्हाट इज दिस लीनियर फंक्शन? इट मीन्स दैट सपोज यू हैव गॉट अ रैंडम वेरिएबल, राइट, x. If you multiply with constant and add the constant here, so it gives you the new random variable by, you can say this is nothing but new random variable by, capital by. As I told you that on the same sample space we can have many random variables. So by is equal to ax plus b. Now you see here, this is nothing but a linear equation. Yes, linear equation, the equation of a line, ax equal to b, ax equal to b, right? So if somebody is asking that, and here they have specified this x is nothing but a Gaussian random variable, right? This is nothing but a Gaussian random variable. Okay, this is nothing but a Gaussian random variable. Okay, mu and sigma square. So x has the expectation of x is nothing but mu, and the variance is nothing but what? You can say the variance is given as mu square, sigma square. ठीक है, ये दिया है. So if someone is going to ask you what is the expectation of by, sir? So expectation of by, you know that this expectation operator is going to operate on this by linearly. Here we can use the linearity of expectation definition property, you can say. ठीक है. So expectation operator is going to operate on this by random variable, ठीक है. और by के जगह में क्या रखना है? Expectation of ax plus b. and this a comes out, so it is a times expectation of x plus expectation of b. You know that the expectation of the constant is nothing but a constant, and expectation of x is going to be mu plus b. तो आप देखो कि if new random variable y is given and it is linearly related with the random variable x, and x is nothing but the Gaussian random variable, okay. So if you know the mean of the random variable x, variance of the random variable x, you can find out the new mean and the new variance for the new random variable y. I think this is clear for all, yeah. ठीक है, you can find out. Now let us try to compute the variance as well, the variance of y. What is variance of y, guys? The variance of y is going to be the variance of ax plus b, right? So here this constant, this is always true, guys. The variance of ax plus the variance of b, and this is going to be 0. So what is this variance? A square in times the variance of x, and this is a square sigma square. Okay, so this kind of question has already been asked in the gate examination. Please remember these points. Okay, so they will give you the random variable, the relation between random variable, okay, and they are linearly related. The random variables are linearly related, and if x is a Gaussian random variable, your y is also going to be a Gaussian random variable. Okay, so you can find out the mean of the new random variable, you can find out the variance for new random variable. Okay, let's say मान लो ऐसा दिया है z is given, which is given as 3u plus 4v, okay, where u and v are the Gaussian random variable, okay, having mean 4 and 5, having 4 and 5 mean हो गया, ये mean है, and variance you can say is nothing but 3 and, okay, like you can take anything, right? 4 and 5 you can say that they have the same mean, okay, same mean, right? They have the same mean, having same mean, you can say 4, and the variance is given as 5, you can say, right? Simple. So what will be the expectation of g? Expectation of g is going to be 3 times the expectation of u plus 4 times the expectation of v. So 3 into expectation of u कितना दिया है 4, 4 into 4. So you can find out the mean of the new random variable g, right? Okay, so this is going to be 28 here. Understand? And the variance also you can compute, right? You can also compute variance, right? So this kind of question has already been asked in your exam. So please do remember this, okay? If you look at the PYQ, you will find it, okay? Okay, please do remember these points. Okay, so let me go ahead and talk about some of the very important points, okay? Very, very important points. Okay. If I ask you how do we compute the probability, computing normal probabilities, normal probability, right? Okay, and if you have got the density function, which is Gaussian density function, so you have to go for integration, right? Okay. तो अगर आपके पास डेंसिटी फंक्शन दिया है, यू कैन से दैट द गॉसियन डेंसिटी फंक्शन is given. The question is, can you find CDF? Can you find CDF? If Gaussian density function is given, can you find CDF? CDF is cumulative distribution function. कैसे find करेंगे सर CDF? CDF definition is nothing but the probability x less than x is going to be equal to integration from minus infinity to x f of x dx. Okay, so your CDF becomes what? It is nothing but a probability, right? Minus infinity to x. Can you plug the formula here for density function? Yes. Square root of 2 pi sigma x square exponential to the power minus x minus mu whole square by 2 sigma square dx. Okay. So you see guys, this is very important now. Okay, so can you compute this integral? Yes. Irrespective of your college, right? Whether you are studying in MIT or any IITs, okay, Stanford, UC Berkeley or anywhere in India, in the world also, right? You are studying in, you talk about any college, right? But can you compute this integral? Can we have the closed form of this CDF? The question is, can we have the closed form of this CDF? So remember that computing this integral is going to be very difficult. Computing this integral is tedious. Okay. Remember, no closed form. No closed form. Okay. Available for CDF. Okay. There is no closed form. Remember this point. Okay. So density function is given. If you want to find the distribution function, so you have to integrate it. But this integration is very cumbersome, very tedious. No closed form is available for the CDF. Okay. But there is a possibility, right? There is a possibility to compute normal probabilities. Okay. So remember that to compute, ये important point है, to compute normal probabilities, normal probability. Now the question is why we call it normal probability, because we are given what, the density function which is normal in nature, right? So that is why we call it normal probability, right? So to compute normal probability for standard normal random variable, remember this, for standard normal random variable, for standard normal random variable, okay, we have the standard normal table, guys. Standard normal table, and in the exam this table will be given, don't worry. Okay, this will be given in the exam. Okay, don't worry about it. Don't okay, in the exam, sorry, I ये टेबल आपको दी रहेगी. This table will be given, guys, don't worry about that. Okay, in the exam this table will be given. So standard normal table, with the help of standard normal table we can find out the probabilities. What we can do, we can find out the probabilities. Okay, since there is no closed form available for the CDF cumulative distribution function, आप ऐसा सोच रहे होंगे सर why we are interested to find out CDF. See, CDF is nothing but a probability only, okay? But density function is not a probability. You have to compute the area under the density function to get the probability, right? But this CDF is going to be a probability, okay? So probability, if you want to compute the probability, first of all, you have to convert the Gaussian random variable into standard normal, and then you can refer the what? You can refer the standard normal table to get the probability. That's it. And it is one of the very simplest job that we can do. बहुत सारे लोग जानते नहीं है इसके बारे में, ठीक है? I think these steps you are following, right? So what we can do here is, देखो ये आर्गुमेंट्स याद रखना जो जो मैंने अभी बताए हैं आपको, ठीक है? These arguments are very important, right? ओके, सो ये पॉइंट आप बहुत अच्छे से याद रखना. क्या पॉइंट है, मैंने क्या बोला अभी तक? आपको याद रखना है कि देयर इज नो क्लोज्ड इंटीग्रल फॉर द नॉर्मल डिस्ट्रीब्यूशन. ओके, there is no closed form for the integral of the normal PDF. As such, there is no closed form CDF. However, we can use a transformation of any random variable, or you can say of any normal to standard normal with the pre-computed CDF. That standard normal table will be pre-computed CDF, okay? Understand? That table will be given. The result of this mathematical, you can say, gymnastic is the CDF for normal random variable X, where the mean is mu and sigma square, right? So we have to convert any normal random variable to a standard normal, ठीक है? देखिए कैसे convert करते हैं. That is very important to remember, guys. Okay? How do we remember? Okay, then we will see how to compute the probability. ठीक है? तो हमारा मेन काम क्या रहेगा सर? We have to learn how to convert. We have to learn how to convert this any normal, okay, any general random variable to, you can say, the standard normal, right? ठीक है? That we will see. So you can assume that the our random variable by, which is normal, if it is normal, right? So can you standard normal, if it is standard normal, so can you tell me what will be the mean of this random variable? The mean is going to be 0 and the variance is going to be 1. Mean is going to be 0 and the variance is going to be 1. By default, you have to say. Now you can find out the CDF for this. The CDF for this random variable by is going to be f by, like this, capital F by, and it is nothing but a probability. It is nothing but a probability of by less than or equal to small by. Okay, and this can be computed directly from the standard normal table, guys. It is going to be nothing but this. This is a Gaussian curve, right? Okay, this is a Gaussian curve, right? Gaussian curve, right? And what they are asking is, they are asking you to compute, there is some small by, and they are asking you to compute the probability by less than small by. What is the meaning of probability less than small by? If density function is given, so they basically want to compute this area. Okay, and this area, the value of this area, okay, the probability, you can say, or the area under this density function till by, from minus infinity to by, is going to be what? The answer for this question. Okay, the answer for this question. I think this is clear, right? ये point याद रखना guys. Okay, we have to refer we have to refer what the standard normal table, right? So this can be written as this kind of a, later you can use phi of y. So again, let me write phi of y, okay? Or you can say that your CDF is going to be equal to the probability capital Y less than small y, and which is nothing but your standard normal, you know, density function. Okay, standard normal density function, I mean it will be the area under this, okay, till by, ठीक है, ये आप याद रखना guys, okay, and the standard normal table will be given, don't worry, okay. अच्छा ठीक है. So suppose we have to compute phi of 0. What is phi of 0, right? What is phi of 0? The phi of 0 is going to be, phi of 0 is nothing but what? You can now forget about this notation, right? Just forget about this notation. You can use directly phi of 0, right? So phi of 0 is going to be the probability they are asking pi less than 0. And this pi is what? This is the density function fy by, which is standard normal random variable whose mean is 0. So since it is symmetrical about by, yes, it is symmetrical about by, okay. So can you tell me the area under this? What is the area under this? They are asking by, you know, less than 0. So this can be written as 1 by 2. Now you may be thinking, sir, why you have written 1 by 2? Yes, as long as we know that the area under the density function must be equal to 1, but it is symmetrical, okay. They are asking you to compute. They are asking you to compute probability by less than or equal to 0. It means half of the area you have to write here. That is half. Answer is going to be half. Yes? Answer is going to be half. Okay. Answer is going to be half. Just I'm going to take one table as well for you, right? So that table you have to remember, right? Just 1 minute. I'm just showing you that table. And how to look that table also I will tell you. Okay. So I believe this is fine for all, yeah? So if someone is going to ask you, what is the CDF at 0? CDF at the value that the random variable takes is 0 is going to be the probability by less than 0, which is 1 by 2. It is only true for Gaussian random variable, and if the Gaussian random variable is normal, standard normal. It is true for standard normal, okay, random variable, okay. If someone is going to ask you what is the probability by greater than or equal to 0, that will be also half only, right? So it is equal to, you can say, by greater than or equal to 0. That is also okay. Understand? Okay. Because suppose someone is going to ask you like this, the probability of by, sorry, I should not write like 1 minute. Suppose somebody is going to ask you what is probability of by greater than or equal to 0, you will say that 1 minus the probability of by less than 0. Yes, so 1 minus, it is nothing but 0.5. It's 0.5. Yeah, you just quickly draw this. You should be habituated drawing these things, right? So ये वाला area अगर 0.5 है, so this area will also be 0.5. So that total area should be, you know. Now the question is why I'm saying area, right? So you should know that, you know, In continuous random variable, whenever probability we want to compute, the probability will be nothing but an area under the density function, right? So probability computation means area computation, right? You have to compute area. That is the acceptance that you have to do. Okay. So that table I just want to show you. Table is important. So I think I can get the table here. Yeah, I got the table. Okay. That table you can see here. This is nothing but a standard normal table. Just I think you are able to view it. ये standard normal table है. We call it standard normal table. If the random variable is standard normal, remember, then only we can use this table, right? So suppose I want to ask one question, right? Suppose we have to compute. Suppose we have to compute one value, right? Let me show you what value we have to compute. Okay. So that you can refer this table and you can get the answer very quickly. Okay, and you must know also that the probability can also be represented with the help of percentage. So you don't have to worry about this percentage or percentage to decimal conversion and all. You should know all these things. It's a very simple thing, right? अच्छा ठीक है, एक क्वेश्चन मैं पूछता हूँ, व्हाट इज द वैल्यू, जैसे मैंने अभी आपको बताया, राइट, कि व्हाट इज द वैल्यू फाई ऑफ जीरो. So phi of 0 is nothing but the probability by less than 0. So phi of 0 means what? You have to go to 0 here. You see here, you have to go to 0. It is 0.00, right? And you have to go to, after decimal also there is a 0, right? So the answer for this question is what? 0.5. However, you can say from the symmetry, answer is going to be 0.5. But from the table also you're getting 0.5 here, right? मान लो क्वेश्चन पूछता है, सपोज लेट मी राइट हियर, सपोज दे आर आस्किंग क्वेश्चन एज व्हाट इज द वैल्यू ऑफ फाई 1.16. what is the, this is nothing but a normal probability we are computing. It means they are asking by less than 1.16. ठीक है. So this 1.1, where is 1.1? This is 1.1, right? You go to 1.1 and then you have to take 0.6 as well, right? So 0.6 is going to be this. So 1.1 and 0.6, right? So this is the answer. You can say that the answer is going to be 0.8770 something. Yes? $0.8770. Yes? See, the table is given and phi 1.16, you have to take 1.1 in the vertical line and you have to go to rows, right? You have to go to horizontally, right, for after the decimal point, right? And you can quickly find out the normal probabilities, right? Provided, please remember this, provided you have to convert your random variable to standard normal. Standard normal means the mean must be 0 and the variance must be 1. तो आपको मान लो कोई क्वेश्चन पूछता है, सपोज somebody will ask you what is the value of probability by less than 2.9. इसका मतलब क्या हुआ? It is nothing but a normal probability they are asking at 2.9. Phi 2.9. Can we refer the table? Yes. 2.9 कहाँ पर है? देखो ये है 2.9. This is 2.9. Right. So this is 2.9, and after that nothing is there, right? So the answer for this question is ye minus 0.9981, right? Certainly in your mind, one question might be there, sir. Suppose they are asking for negative value of random variable. What is the probability for negative value of random variable? ऐसा क्वेश्चन आपके माइंड में आ रहा होगा, ठीक है? Suppose they are asking this, what is phi of -2, which is nothing but the probability, okay, y less than -2. Okay, what is this? So one point I just want to highlight here is, as long as the symmetry property is concerned, this is one of the beautiful observation. आपको हमेशा याद रखना है, ये सिमेट्री आपकी लाइफ को सिंप्लीफाई करती है सर. Your entire life is getting simplified because of this symmetry word. ठीक है, अगर आपके पास सिमेट्रिकल सिचुएशंस होती हैं, देन योर लाइफ इज वेरी सिंपल. ओके, सो फाइव ऑफ -2, अगर आप इसको देखो, दिस इज माय गॉसियन density function, right? And they are asking this y equal to -2 here. They are asking this area, this tail area, you can see. This is the tail of the density function, okay? Tail. So whatever area will be this, the same area is going to be this also, y equal to 2. ये वाला area and this area, both areas are same only, guys. Can we say like this? Yes. Probability by greater than 2 and probability by of less than -2, both areas are same because of symmetry. Okay, because of symmetry, this area and the both tail areas are going to be same. I think this is clear for all, right? ठीक है, remember this point. Okay, so what we can say that instead of finding this area, you have total area that is nothing but you have total area that is nothing but 1 minus the area. You have to, at the end of the day, what you have to find? See, you have to find this. Okay, what you can do here is, you can take the total area 1 and you can subtract the area till this point so that you can get this. Okay, this is the idea. मैं क्या बोलना चाहता हूं, देखो, मान लो तुम्हारे पास एक ये गॉसियन डेंसिटी फंक्शन गिवन है, and if you want to find this area, okay, which is nothing but what, which is not a phi of -2, remember this, sorry, which is, you can say, kind of phi of -2 only. Okay, a phi of -2, you can say this is phi of -2 only. So if you want to find this area, right, so what you can do here is, if you want to find this area, so this will be equal to 1 minus the total area is going to be 1, area under density function is 1, and remember this density function is nothing but standard, right? Standard density function. So 1 minus the area of this till this point, that is phi of, you can say, 2, and this is going to be equal to phi of -2. ठीक है, so जब भी नेगेटिव की बात आएगी, whenever you will get for negative, right, so just take 1 minus from the table, you can subtract that probability, that's it. Okay, you will get the answer. ठीक है, चलो ठीक है, let me compute here. So they want to know what is phi of -2, which is nothing but your this the CDF, okay, which is going to be your probability, and the value is going to be, you can refer the table, so this will be 1 minus phi of 2, which is going to be phi. What is phi of 2, guys? From the table is this phi of 2, ये 2 है, and this is negative decimal 9772 to 1 minus 0.9772. तो अगर आप इसको सब्ट्रैक्ट करते हो तो यू विल गेट द आंसर, राइट? सम आंसर यू विल गेट. ओके, I think now you guys understood this, yeah? सो ये सबसे इंपॉर्टेंट सिचुएशन है. एज लॉन्ग एज द डेंसिटी फंक्शन इज सिमेट्रिक, योर लाइफ मस्ट बी वेरी सिंपल. ठीक है. तो पहला पहला बात क्या याद रखना है, इंपॉर्टेंट फॉर क्विक कैलकुलेशन, राइट. आई एम जस्ट गोइंग टू मेंशन हियर, यू कैन पुट इन द शॉर्ट नोट एज वेल. इंपॉर्टेंट फॉर क्विक कैलकुलेशन. Okay, so most of the time they will give you area under the density function in terms of probability. Okay, but sorry, in terms of percentage, right? Probability as percentage, right? So percentage को आपको decimal में convert कर लेना. जैसे 95% means 0.95 like this. So first you have to remember is your density function is kind of symmetrical only, right? So if someone is gonna ask you what is the probability of bi less than 0, so this area you have to take, which is 1 by 2. इसको आपको notation भी pi में भी कर लेना है. Okay, and suppose somebody is going to ask you what is phi greater than 0, which is nothing but 1 minus probability of bi less than 0. So okay, so because of this symmetry we are writing this. This is because of symmetry, you can say this, right? So 1 minus 0.5, which is 0.5. ठीक है. And the second point that you have to remember is, suppose they are asking you to compute something like minus pi. So this can be written as 1 minus, okay, ये पॉइंट आप याद रखना. इसका मतलब क्या होता है, they just want to know what is the area of this, right, total. So first you have to just take 1 minus this. Okay, so anything you can compute, don't worry about this normal table, they will give you in the exam. चलो अब बात करेंगे सर एक कॉन्सेप्ट की. दैट कॉन्सेप्ट इज नथिंग बट स्टैंडर्डाइजिंग एंड रैंडम वेरिएबल. हाउ टू कन्वर्ट standardizing, right, random variable. Okay, how to convert any normal random variable to standard normal random variable, that is a question. ठीक है. So suppose first is any random variable is given. Okay, any normal random variable which has mu, x is a normal random variable which has mu and the sigma x square is the variance, right? ठीक है. So you have to consider let g you can take or by whatever you want to take, right? But let me take g here, okay, because this g has very big you can say importance, right, in statistics, right? In statistics it is very important. For data science people, for computer science people, this g is very important. So what we can consider here is, let us take g. Okay, we are going to make assumption here, g is going to be, and we will claim that this g is nothing but standard normal random variable, sir. अब देखो कैसे हम क्लेम करने वाले हैं. इट्स अ वेरी इंपॉर्टेंट गाय, ओके, इन आवर फैमिली नाउ. ठीक है. सी एक्स इज अ काइंड ऑफ जर्नल नॉर्मल रैंडम वेरिएबल. कोई भी गॉसियन रैंडम वेरिएबल है जिसका मीन नॉन जीरो है, वेरिएंस यूनिटी नहीं है. ठीक है. बट एज लॉन्ग एज वी वांट टू कंप्यूट द प्रोबेबिलिटी, नॉर्मल प्रोबेबिलिटी, राइट, सो वी नीड what? We need standard normal random variable, right, so that we can refer the standard normal table. ये रिक्वायरमेंट है, कहते हैं ना, नेसेसिटी इज द मदर ऑफ इन्वेंशन. ओके, सो Z is going to be what? So Z is going to be, you can write, you could take the random variable which is given in the question. X is nothing but a, general Gaussian random variable. Subtract from this X, that is mu. It is nothing but what? Kind of deviation we are finding, X minus mu. Upon, you have to divide by the deviation, guys. Since X minus mu is also a deviation only, right? So you have to divide by the deviation. Okay, so X minus mu by standard deviation, right? So this is called as standard normal random variable. स्टैंडर्ड देखो, बहुत ही इजी तरीका मैं बता रहा हूं. आपके पास अगर कोई भी रैंडम वेरिएबल गिवन है which is not the standard normal random variable, what you have to do, you subtract the mean of the given random variable. x का जो मीन दिया हुआ है उसको क्या करो, subtract करो and then divide by the standard deviation. So your random variable will become the standard normal random variable, sir. And you will say, sir कैसे आप बोल रहे हो, हवा में बोल रहे हो क्या? हाँ, बहुत सारे लोग हवा में ही बोलते हैं, पूरे इंडिया में हवा में बोलते हैं, मैं आपको बता देता हूं. बट आई विल प्रूव हियर, आपको मैं दिखाता हूं कि दिस जी, ये जेड जो है ना, जी, आई लव टू कॉल इट जी. जी इज नथिंग बट स्टैंडर्ड नॉर्मल रैंडम वेरिएबल. देखो कैसे, याद रखना, एनी random variable, any normal random variable, you can say any normal random variable having mu and sigma x square x, you can say, if you want to convert into standard नॉर्मल रैंडम वेरिएबल, तो आपको करना क्या है, यू कैन कंसीडर दिस जेड इज नथिंग बट अ स्टैंडर्ड नॉर्मल रैंडम वेरिएबल. सो टेक द एक्स, माइनस करना है म्यू अपॉन सिग्मा. एंड आई पर्सनली क्लेम दैट दिस जी इज नथिंग बट द स्टैंडर्ड नॉर्मल रैंडम वेरिएबल. दिस इज standard normal random variable. Okay, so wherever you might have seen, right, wherever you might have seen x minus mu by sigma, you can replace that, okay, with the help of this g. That is called substitution, right? You can just substitute this. Okay, अब देखो, if it is a standard normal random variable, it means that this g can be written like this now. It should have zero mean and the variance must be equal to 1, sir. Yes, ऐसा है ना, यही बात तो है. Yes. So Dheeraj sir, can you show me g has zero mean and standard g has zero mean and the variance 1? So I will say yes. देखो, x is any normal which has mu and sigma x square is the variance. Now what we are doing here is we are converting this guy into g and we are claiming that this is 0 and 1. वे कैसे हो रहा सर? Can you prove this? Yes, देखो, proof. I have considered g equal to x minus mu upon sigma x. Okay, that is the standard deviation, right? Now let me find expectation of g. Expectation of g is nothing but expectation of x minus mu upon sigma x. Since sigma is going to be your constant, so you take sigma out. 1 by sigma x, expectation of x minus the expectation of mu. कोई दिक्कत है यहां तक? Okay, and you know that 1 by sigma x, what is expectation of x? That is mu minus what is expectation of mu? That is mu only, and now it is 0. Very simple algebra, very simple manipulation. ठीक है. So G is having the mean, Z has the mean 0, and it is following the criteria to become a standard normal. Yes. And can we find out the variance as well? Yes, sir. The variance of, okay, let me write variance. Variance of G is going to be variance of x minus mu by sigma x. So you know that 1 by sigma x is nothing but a constant, so it becomes 1 by sigma x square जब ये बाहर आएगा, and this is nothing but variance of x minus the plus, you can say variance of mu. Variance of mu is gonna be 0, guys, क्योंकि variance of the constant is constant, right? So it is nothing but and sigma x square by sigma x square, which is 1. So you can claim that G is absolutely a standard normal having 0 mean and the variance 1. Okay. So in statistics language, this G is called as G score. This Z is nothing but, we call it G score, sir. G score, which is calculated as x minus mu upon sigma in statistics. Okay, and this kind of question was also asked in GATE data science in AI paper, right? Nobody knows this. मैं आपको बता दिया हूं, बस कोई जानता नहीं है. Okay, how to convert a random variable, any normal random variable to a standard normal. That is a small trick. ये बहुत ही easy trick है. Okay, so so I think this is clear for all, and you guys can just have a look, right? So if x is normal, you can go for right, you can find out. ठीक है. अब देखो नेक्स्ट सेशन में हम लोग मिलेंगे एंड वी विल ट्राई टू कंप्यूट द नॉर्मल प्रोबेबिलिटी, राइट, अगेन. So for this is enough. I hope you might have enjoyed the session. Thank you so much. Keep learning.